question number 2 is given as question A. For a Compton scattering, so that the change in the wavelength of the scattered radiation is del lambda is equal to h by m naught c into 1 minus cos phi, where m naught is the rest mass of electron and phi is scattering angle of photon and h is the Planck constant. Okay, so it is a standard derivation. So if initially the electron is in rest, so rest mass is m naught, this is electron, and one photon is coming from here. So if the energy of photon is this E gamma, and it heated the after heated it scattered from electron in this way. So if this is the scattering angle of photon, that is phi, and this is the recoiling angle of electron, so this is the theta. Okay, then we can easily show that the change in the wavelength of this scattered photon is equivalent to this form, that is h by m naught c into 1 minus cos phi. With the help of firstly we have to implement the momentum conservation law, and as well as in both directions along x and along y, because for scattered photon and scattered electron they have two different components for velocity along x-axis and along y-axis, so that we have to consider both component, x component and y component. After applying the momentum conservation as well as energy conservation, we can easily find this form. Okay, you can get this derivation from any standard book. Okay, so this is the Compton shift formula. Okay, this h by m naught c into 1 minus cos phi. Here this term, that is h by m naught c, it is called the Compton wavelength, denoted as lambda c. Okay, so next question is why Compton effect cannot be observed with visible light. We can explain, or we can show it using mathematical expression like that. Here see, the Compton shift is defined as this, that is the del lambda. Okay, h by m naught c into 1 minus cos phi. If we find out for only for the Compton wavelength, that is for the electron, that is h by m naught c, then it gives in order of 10 to the power minus 12 meter. But in case of visible light, visible spectrum, that is the order of 10 to the power minus 7 meter approx. Okay, but here the Compton wavelength is matching with is order of the X-ray wavelength. So if we find the fractional change in the wavelength, then we get 10 to the power minus 5. It is very less than 10 to the power minus 5. That's why you cannot see Compton effect in visible light. So it's far too small to measure experimentally with visible light. Okay, next one is photoelectric effect and Compton effect are due to the action of photons on electrons. Okay, but their two effects are not same, obviously. Explain. So we can explain like this, that is, in case of photoelectric effect, photon, we have a metal sheet. Okay, then a photon imparted on that metal sheet, and that photon absorbed by this metal. That means the energy of the photon is completely transferred to the electron, bounded electron of that metal. Okay, so here photon is completely absorbed by the bound electron in solid. But in case of Compton effect, photon is scattered and almost free electron. Okay, so in case of photoelectric effect, photon is absorbed completely by a bound electron, but in case of Compton effect, photon is scattered by an almost free electron. Second one is for photoelectric effect, the energy of the electron, that is the ejected electron, is defined as phi work function plus kinetic energy of electron. But in case of Compton effect, the energy and the momentum both are conserved. So energy and the momentum shared between scattered photon as well as the recoil electron. Third one is emitted electron leaves surface, no scattered photon. In case of photoelectric effect, since photons completely absorbed by the electron, so there is no scattered photon. But in case of Compton scattering, there must be scattered photon. Okay, so photon changes its wavelength instead of being absorbed. Photon just changes its wavelength. So both involve photon electron interaction, but they are different physical process, and energy sharing are different for both cases. Okay, next question is question number D. It is a numerical problem. So light wavelength is given 4500 angstrom, ejects photoelectron from a sodium surface, work function is given 2.3. okay, the stopping potential is experimentally found to be 0.46 volt. So calculate the value of Planck constant. Okay, so using Einstein equation we have to calculate the Planck constant value. So here lambda is given 4500 angstrom, that is 4500 10 to the power minus 10 meter. Next, phi work function is given as 2.3 electron volt. Okay, now stopping potential is also given, that is the V stop is given 0.46 volt. So in general we know that the Einstein equation, that is h nu, so that is the energy of photon, incident photon, is equivalent to phi work function plus kinetic energy of electron, sorry yes, so kinetic energy of electron k max, maximum kinetic energy. Now this maximum kinetic energy in case of stopping potential, if we read seriously the definition of the stopping potential, then we can equate this kinetic energy with the E V naught, that is the E is the charge of electron, and V naught, or sometimes it is mentioned at Vs, that is the stopping potential. So this K max is equivalent to E Vs, E times Vs, stopping potential. So here that nu is C by lambda, so AC by lambda. So here we get AC by lambda equals to this phi value plus this E into Vs. Okay, so from here we have to calculate this all value. So here H equals to nothing but lambda by C times phi plus EVS. So if we substitute all the values, then we can get the value of H, that is 6.63 into 10 to the power minus 34 joule per second. Okay, so this is the value of H we can easily calculate from the Einstein equation. In general, if we perform the experiment, and that is finding the Planck constant, there we naturally calculate H from the graph, from this graph, that is AC by lambda equals to phi plus EVS. So here phi is constant, this E is constant, and Vs. So if we write this like 1 by lambda, or sometimes it can be written as only nu, then it will be phi divided by H plus E divided by H into Vs. So if we plot this nu versus Vs, that is y equals to mx plus c. So if we comparing this general expression of straight line with this, then we can easily get the slope gives us E by H. From here we can get H value, and also if we plot the line here, plot the straight line here, the cutting, the y-axis cutting also gives us the age value if we have the phi value. Okay, if we know phi from the y-axis cutting, we also can find the age value. Okay.